Hi, my name is Shaika Ganj. I'm a principal applied scientist with Amazon SageMaker. I'm one of the original inventors of AWS DeepRacer as well as AWS DeepRacer Evo. I also lead the science and engineering teams working on applying deep reinforcement learning to business problems in Amazon SageMaker. I'm really excited to be here today. In this workshop, we're going to be talking about how we can replicate the AWS DeepRacer architecture to Amazon SageMaker, where we can go beyond what AWS DeepRacer Console offers today. So I'll be talking about it a little bit towards the end of our discussion, towards the end of our workshop as well. Let's get started. Let's take a recap of what you have done so far in your journey with AWS DeepRacer. We expect you to have taken 200 or 300 level workshops, so you are familiar with the DeepRacer, deep reinforcement learning concepts. We also expect you to have configured AWS DeepRacer using Garage, as well as engineered a reward function, and trained and evaluated your DeepRacer models either in virtual or real world. What we will be doing in this workshop is we're going to use the AWS DeepRacer architecture, and we're going to replicate it in Amazon SageMaker. After we do that, we're going to do a deep dive into one of the concepts in deep reinforcement learning, which is the neural network architecture behind the agent's behavior. And then we're going to learn about how we can take our learnings from AWS DeepRacer, the reward function engineering, neural network modifications, and so forth, and apply it to real-world problems where deep reinforcement learning provides state-of-the-art solutions, as well as outperform known supervised and unsupervised models. And finally, we're going to give you new opportunities that are coming up in 2021, where you can take the learnings from this class and compete against many participants coming up in 2021 for AWS DeepRacer. Let's start out with the SageMaker notebooks. Before we get started, let's take a look at the architecture behind AWS DeepRacer. There are basically two main components behind AWS DeepRacer. These core services are the components that are SageMaker and RoboMaker. AWS RoboMaker is a simulation environment that supports Amazon SageMaker. Amazon SageMaker does all the training that is needed for your reinforcement learning agent to become intelligent over the course of its learning. And AWS DeepRacer uses Amazon SageMaker in the background, while the Amazon SageMaker orchestrates all the services underlying DeepRacer. Hence, today's workshop is going to be focusing on this component at the top that you see as Amazon SageMaker that provides the training environment. Let's take a look at what you can do today with AWS DeepRacer and how you can go beyond that with Amazon SageMaker notebooks. First of all, in the Amazon DeepRacer, you are giving multiple tracks, and you can compete against these multiple tracks. With Amazon SageMaker notebooks, you can go beyond these tracks and you can create worlds, such as you can take DeepRacer and have it trace and run a race on Mars or on Moon. This means that you can create new worlds using the SageMaker notebooks. In addition, using the SageMaker notebooks, you can quickly add new sensors. Today on the DeepRacer, we have two cameras, and in the back we have a LiDAR. But with SageMaker notebooks, you can add proximity sensors, and you can go beyond the applications that we provide outside of racing. In addition, SageMaker notebooks enables you to take your training to the next level. With the notebooks, you can create multiple simulation environments and learn your neural networks from all these simulation environments at the same time. So you can iterate faster, and you can quickly check whether your reward function engineering is creating new rewards that are outperforming the previous ones. And finally, you can evaluate your models in previously unseen tracks, such as the case in Mars. But most important of all, one of the core concepts of deep reinforcement learning is the neural network architecture that enables you to learn a certain track. So today's workshop is going to be focusing on doing a deep dive into how we can change the neural network and learns the pros and cons of modifying the neural network on our reward function and the performance of your reinforcement learning agent in general. How do we go about it? Before we do a deep dive into modifying our neural networks, let's take a step back and try to figure out how our reinforcement learning agent learns. Reinforcement learning works in a feedback loop. At the very end, we have our neural network. And this neural network is initialized with random weights. These random weights are first used to gather experiences using the simulation application, which we host in AWS RoboMaker. After these experiences are gathered, we push them through a gradient descent. And gradient descent learns the new neural network weights by maximizing a cumulative discounted reward function. The cumulative discounted reward function is critical because this is where the reinforcement learning agent learns a long-term horizon. So it's not only learning the action it has to take here and now on the track, but it's looking ahead. If I were to use this neural network and if I tried to go over the track, what will be the cumulative reward I would get? Hence, you can imagine that depending on the reward function that you had engineered, there is a correlation between this reward function and the neural network architecture that enables the agent to learn to maximize this reward. This concept is very similar to how you would come up with different models when you're applying supervised learning or unsupervised learning to data labels. So now your data in this case is cumulative discounted rewards, and the data that you're gathering is the experience that you obtain from your simulation environment. Let's take a look at what are the pros and cons of using a deep neural network architecture. First of all, we started our workshop saying that if you have deeper networks, you can potentially get a better approximation, and this better approximation leads to higher rewards in a shorter amount of time. This can happen on a variety of reward functions. While you are working on beating your competitors in AWS Deep Racer summits and races, you had spent a lot of time coming up with the best reward function that you can design to get a higher reward. Now, if you look back on different kinds of reward functions that you have, you can imagine that what we had seen in our experiments is if the reward function is not as piecewise linear, that it has these on and off moments, that you get rewards if you're on the track and no rewards if you're off the track. You get reward at the end as a bonus when you complete the track, as opposed to getting progressively more and more incentives as you go around the track. For these types of reward functions, we had seen over and over that deeper neural networks provide better performance and higher rewards around a faster amount of time. Now that we had established that, what are the cons, what are the disadvantages of having to use deep neural networks? As you all know, that shallow networks have smaller number of layers and it can be trained much faster. On the other hand, if you have deeper networks, these are going to take a longer time to train. However, this is where really SageMaker comes into picture. SageMaker provides you with different kinds of GPU instances, and you can quickly turn this disadvantage to advantage using various different kinds of GPU instances SageMaker provides at various cost levels and you can get the most out of this advantage and turn it upside down. Another disadvantage that you may face is when you do simulation to reality transfer. We had seen that some of the deep neural networks do not transfer as well into the real world due to delays it takes for these neural networks to run inference on the AWS DeepRacer device. Let's consider an example and look at the plots that we would see if we look at the progress. So imagine that we have a reward function that is getting incentive to the vehicle, or incentive to the agent in this case, when you are on track, and no incentives when you go off the track or when you hit an object or one of the cars. And you only get a reward also when you complete the track without hitting any of the stationary or moving objects. So this means that we don't have a piecewise linear reward function, but it's a relatively simple reward function to design. Now imagine on the y-axis that we will be looking at the progress the agent makes as it's learning this new reward function. Now imagine that on one side we have a shallow network that we're using for the agent, and on the other we have a deeper neural network. If you look at these two curves and think about the pros and cons that we talked about. One of the pros was that we can get higher rewards. Now look at our graphs. On the shallow network, after 400 episodes, our vehicle, our agent, is able to learn to go over the 60% of the track. On the other side, when we look at after 400 episodes, our deep neural network is able to do 80% of the track. So it's achieved a higher progress rate across the track. Now let's take a look at the other pros and cons. We said that it's going to potentially take faster to train depending on how deep your neural network and depending on your reward function. So if you look at the 60% progress and we look at when these agents reach 60% coverage across the track, we saw that the deep neural network can achieve this twice as fast compared to the shallow neural network. So this is one of the advantages that we had seen if we were to create the deep neural network for an agent as opposed to the shallow neural network that you had set. So you can potentially put the boundaries of how many rewards that you can get and beat your opponents in the upcoming races. Now, before we deep dive into how we can modify the neural networks, let's take a look at what actually the neural network looks like. Remember that this exercise that we're going to have for you during the workshop is going to be based on the EVO, where we have two cameras and we have a LiDAR. The two cameras are capturing a 2D image. Hence, in our neural network, we're going to have an input head for this, which is going to be using the 2D image, and it's going to pass it through convolutional neural networks. So these convolutional neural networks will literally enable these both stereo cameras to learn to look at different parts of the track where it enables it to learn not to go off track, not to hit an object and move around them. The similar thing is going to happen with the LiDAR. But now imagine that when your car is going forward, it's probably going to see things first with its cameras, but when they're passing them, it's going to see them with the scanning LiDAR we had provided for you. The scanning LiDAR is going to be seeing a flat plane, hence the image that it's going to come in, the input that it's going to come out is going to be a 1D vector. Hence, we're going to pass the input that is coming from the LiDAR through 1D layers, maybe 1D convolutional layers that you can apply. Now that we have our 2D convolutional neural networks and we have our LiDAR, In the middle layer, we're going to combine all this information, because as your car is moving forward, it is seeing the cars in the front, and then it is seeing the cars in the back. So you will be combining all this information that is passed through several layers of convolutionals and one-dimensional and merge them in the middle layer. The output layer, you will not be able to make a change because the output layer is depending on the actions. Irrespective of the sensor data that you have, your car is limited to the number of actions it's going to make, and the number of actions is tied to the number of nodes in your neural network output. Hence, we won't be able to make changes. Now you are ready to follow the link to our website, where we provide you with a step-by-step workshop where you can modify the neural network. Also, to get this started really fast, we provided some templates when we provided these templates, we provided you with several options where you have deeper layers in the middle, which means that you're really paying attention in your agent training to use the sensor fusion, and you're putting importance on that as you're deepening your layers. Additionally, you can deepen the layers on the convolutional neural networks, and this is where the perception comes into the picture, where you're deepening perception in training your agent. So we provided you with templates, and we strongly encourage you to follow the link and try out these different neural networks where you're either deepening the architecture to get more from the perception, and or you're deepening the middle layer to get overall sensor fusion data so that you can learn how to pass the vehicles a little better as opposed to deepening in the perception. Now let's take a pause here and change gears a little bit. In your 200 and 300 level courses, you got familiar with Deep Racer, you got familiar with fundamental concepts of deep reinforcement learning. And that is how I actually started my deep reinforcement learning journey at Amazon. It started out with AWS Deep Racer. It provided me with hands-on experience to understanding various concepts. Now, what I would like to do in the next few slides is give you a little bit of perspective of how I used AWS Deep Racer, how I used my learnings there in order to solve real business problems, real-world problems, business problems, and use cases where deep reinforcement learning made a significant improvement in the state of art and outperform supervised and unsupervised learning. So I'm going to give you a few examples where you can have an understanding of how you can take your learnings from Deep Racer and apply to your business case as you get more advanced and learn more about deep reinforcement learning. Let's do a short recap on the deep reinforcement learning for Deep Racer. In Deep Racer, you learned about 4 different concepts. The first concept that you learned was you have an agent, and this agent uses a feedback loop to learn a long-term objective. While doing that, this agent is a neural network, and today you learned how to actually modify this neural network architecture to get better performance from your reinforcement learning agent. Reinforcement learning agent makes observations and takes actions. And Deep Racer also uses a simulation environment, so you learn to use a simulation environment to experience how your neural network agent is going to perform. And finally, you spend a lot of time in Deep Racer engineering the reward function and really seeing that behavior come into life in virtual environment as well as in the real world tracks. Now let's see how these different 4 concepts of core components of deep reinforcement learning that you now have learned from DeepRacer translates to different problems and real business use cases. Let's take a look at gaming. So you might have thought about, well, DeepRacer is really look like a gaming environment where I'm trying to race a car, which is true. Capcom, one of our customers, builds fun games faster using managed services on Amazon SageMaker. Now imagine these four concepts, and your neural network agent now consider this is a developer, and it's playing a game, and it's taking actions similar to the DeepRacer, where it's going back and forth, moving right and left. And instead of AWS RoboMaker as a simulation environment, imagine it's one of the cutting-edge gaming engines such as Unity. And now you are getting rewards by completing levels. So this is very similar to DeepRacer, but instead your simulation engine now is a gaming console, and your agent is playing a game, and it is beyond a racing game. Now, using these four core concepts and mapping into gaming applications, you can unlock many things. You can design better games before they go into production. You can understand how an agent can learn the game fast and maybe potentially find bugs in these games and really improve and harden your gaming environment before it goes into production. Let's take this to the next level. Let's get out of the gaming and see how our industrial companies are taking this reinforcement learnings from DeepRacer and applying it to problems where they're getting better performance from their actual assets. Now, remember those four core components? And now our neural network agent is a real-time control system taking actions such as pitching a blade of a wind turbine and pitching this blade a little differently and learning it in a simulation environment where you have high fidelity physics. So you can really model by pitching the blade how fast you're going to get wind and get energy from your wind turbine, and use this as a reward to learn how to pitch the blades of a wind turbine better. So in this case, your DeepRacer experience is coming into picture where your agent is a neural network agent and it's actually a controller taking actions by pitching a blade a little bit to the left, a little bit to the right. And your simulation environment now is not a gaming environment, but a high-fidelity physics engine such as MathWorks, MATLAB, or Simulink that enables you to model the energy that the wind turbine is going to generate. Now let's imagine that instead of trying to learn to go over a track in a faster timing possible, you're trying to get the best energy out of the wind turbine as fast as you can. And you keep doing this over and over in a simulation environment, and you finally learn how to deal with the high winds or maybe the slow winds, and you really have a hardened agent, an AI agent that you can deploy in production and knows how to deal with the high winds, slow winds, and get the best out of your wind turbine. I'm really excited to learn about the different use cases that you may have where you consider these four components that you had learned from DeepRacer and apply it to your business problem. And once you do this in your reinforcement learning journey, you're 50% there. The Amazon SageMaker notebook that we provide you for DeepRacer is able to take these four different components and enable you to take the next journey, to take the next step in your journey in your deep reinforcement learning. And now let's take a look at where you can apply these new learnings. In 2021, we're going to be opening different kinds of leagues. We're going to have an open and pro league. So in the open division, what you can do is you can learn how you can modify the neural network and take these learnings from this workshop, as well as your 200 and 300 level. And if you get into the top 10, you can move on to the pro level and compete against the best, the cream of the crop, and get more advanced in your deep reinforcement learning journey. Now, we also have digital rewards coming up in 2021 in the console environment. And finally, you will be getting more merchandise, and we're going to have special sponsored events as you excel in both open and pro divisions, get digital rewards, as well as special sponsored events. You get closer and get more advanced in your deep reinforcement learning journey. And I'm really looking forward to hear about how you can use today's learnings on replicating DeepRacer on Amazon SageMaker and learning your top 10 learnings from DeepRacer, applying to your business cases to outperform previously known methods in supervised and unsupervised learning. Get racing!